Now you may have been wondering why we haven't been evaluating any logs on our calculator, and the reason for that will become clear in this video. In order to answer that question, I need to describe what's called the common log. When we write the symbol log without a base, so that means just log, no subscript, rather than log with some subscript b, we're referring to what's called the common logarithm. In our context, and for calculators, that means the logarithm with a base 10. So if we see just log 100, that means the log base 10 of 100. To write that in exponential form, the base is 10. No base is shown, so it's 10. And then, just like usual, we exchange the argument and the exponent. So the statement log of 100 equals 2 means 10 squared equals 100. And since that exponential statement is true, the log form statement is also true. Okay, so what's so great about the common log? There are a couple of things, but one of them is that the calculator has a button for it. Now you might be wondering, why does the calculator have a button for the common log and not for any old log? And the answer is that historically, calculators didn't have the memory to store any old log, and as we'll see shortly, if we can find the common log, then we can find any old log. At this point, not having a button for any old log is kind of a historical relic, but we're stuck with it because all the calculators do it, and so all the math classes assume that it's that way, and so all the calculators can keep doing it. So where is this button? On the TI-30XS, our log button is just right underneath the second button. If you have the TI-84, the log button is a little bit further down the left-hand column. And the way that this button works on these TI calculators is you press log, and it gives you this log symbol, followed by an open parenthesis, and then you type in the number you want to take a log of. So our first example, we'll take log of 10,000. Close the parenthesis, hit enter, and according to the calculator, the log base 10 of 10,000 is 3. To check that, the base is 10, and the exponent and the argument change places. So 10 to the third is 1,000, and we know that that's true, right? When we take a power of 10, it's just a 1 followed by that many zeros. The log of 0.01 on the calculator, log 0.01, close parenthesis, enter, we get -2. The log of 0.01, according to the calculator, is -2. That means 10 to the -2. Base stays 10. Exponent and the argument switch places. So 10 to the -2, it should be 0.01. Right, 10 to the -2, that's 1 over 100. That's 1/100th. That's what that decimal is. Okay. So that's great, but we could have figured that out on our own because we know a lot about powers of 10. But we can also do this on the calculator. For numbers that are definitely not powers of 10. We can take the common log of 17, for example. And we get some awful decimal. Our instructions tell us that we ought to round to 3 decimal places if we need to. So we have 1.230. Now, if we check that, 10 to the power 1.230, we can do that on the calculator either by typing in 10 to the power 1.230. Or you'll notice that it gives us this 10 to the x as the second function on our log. If we hit second log, that punches in 10 and puts us in the exponent. Either way, same thing. They do the same thing. That second log just gives us a shortcut. But you'll notice that didn't give us exactly 17, which is to be expected, right? If we round the input, we're going to get output that's a little bit off. That's to be expected. But this is very close to 17. We can also take the log of some huge number. So log of 1945. Oh, that's not that much more, right? This is 3 decimal places. It'll be 3.289. If we take 10 to the 3.289, we don't expect to get exactly 1945, but we get 1945 and a little bit. So we get about 1945, as we expected. Okay. Why the log base 10? Why is that the log that they pick to put onto the calculator? And the answer has to do with our number system. Our number system is also base 10. Right, so that's why we have a ones place and a tens place and a hundreds place. Or to the right of the decimal point, we have a tenths place and a hundredths place. Because our number system is base 10, the common log describes what the number looks like. In fact, the common log can be approximated by counting the digits. Specifically, if we have a big number, a number that's more than 1, we can count its digits, call the number of digits n, then its common log, if the number of digits just to the left of the decimal point is n, its common log is between n minus 1 and n. So it's less than the number of digits, but it's more than the counting number before that. So take a look at this example. I've got 19,271. That has 1, 2, 3, 4, 5 digits. Its log has to be less than 5, but more than 4. In fact, if we put that into the calculator, we see that the log of 19271, that is indeed 4 and a bit. It's 4.285. So a number between 4 and 5. What about small numbers? We can look at how small a number is based on where its first non-zero digit is. If its first non-zero digit is n places to the right of the decimal point, then its common log is more than negative n and less than the next number, negative n plus 1. So here we have 0.0083. Its first digit is 1, 2, 3 places to the left of the decimal point, which means its common log is more than -3, but less than -2. And indeed, putting that into the calculator, we see that the log of 0.0083 is -2 and a bit. So it's -2.081 if we round to 3 decimal places again. So part of the reason that we choose the common log is that it's the easiest log to figure out just by looking at the number. At least what two whole numbers our log is going to be between.